Excellent. And we are recording. And Victoria, why don't you kick us off, please?
Great. Let me go ahead and present here and not lose my Zoom. Okay, well, that did not work. Can you all see my screen? The slides?
Yes.
Yep.
All right. So welcome to 0 Day DevOps. This is a talk about the intersection of DevOps and mission critical systems and how the 4 to 5 key metrics about DevOps apply and why everyone should know them. So like I introduced myself earlier, I'm the VP of Operations at Pluribus Digital. We are a women-owned small business in Arlington. Our 2 primary customers are FDIC and USCIS. So definitely talk to me later if you're interested to learn more about our company. We're always talking to folks and getting ready for new proposals. And we do a lot of DevOps and app development and data science type work. I also organize DevOps DC, so check us out. We are now the 3rd Tuesday of every month. So you might have heard from us last week. But I also organize with Women Who Code DC, and we have a DevOps series with them, as well as data science and all other types of languages that are really awesome. So, and I am on Twitter here. And of course, talk to me about rock climbing anytime. I love rock climbing, and I will nerd out about it whenever. And I'm actually at a socially distanced happy hour with Pluribus Digital right now, which is why I might have to pop up right after I leave here. And then I have a D&D game at 8. So just a busy evening for me. But I'm really excited to be with you all here. So this talk tonight started from, I was at a government agile leadership conference and someone came up to my table and I'm manning our table for the first time in my new executive role for the first time. And he asked me like, well, what is DevOps, right? And I think I said something about, it's Dev and Ops together. And it's a cultural movement about bringing software development practices and principles applied to operations, like version control and things like this. And he was kind of like waved me off and was like, oh yeah, whatever. Like, well, we can't do that. We have like big missiles and things. So we can't do DevOps. And I was like, well, actually, the concepts from DevOps still apply. And if you look at the State of DevOps Report from 2019, as well as the book Accelerate by Nicole Fordson, it talks about these 5 measures of software and operational performance, which focuses on the overall system level outcomes, right? So that what they did is they took 6 years of research and data from over 30,000 professionals worldwide and looked at like who were these high performers and what were these commonalities in terms of what they were doing that led them to those high performance outcomes. So those 4 key metrics, one is of course just availability, right? That's the main one, but the 5 ones that are related to that, which we'll get into, is lead time, mean time to restore, deployment frequency, and change fail percentage. So we'll talk a little bit about each of those, and then we can get back into how those apply to systems that are mission critical, right? So this is when I started to like turn his ear and he was interested, right? So lead time is just how long does it take to get from the code from your computer and your laptop successfully running in production. So with mission critical systems, a lot of times there is a lot of approval processes that you have to go through. You have to make sure that you checked in with security. You have to make sure that your government owner approved of this system. Because it's a big deal if it gets into production and it has a problem. So there's often a very long lead time to be able to get there. Or Chrome Cat needs to approve your code, right? Then there's mean time to restore, which is how long does it take to restore your service when an incident or defect happens that impacts users, and it's that all the containers fall over. Like how long does it take to write the ship, right? So that's a really key metric that you wanna have, especially when your systems are super important, right? And then how often are you doing deployments? This is the one that I think that people struggle with with these mission critical systems is that they don't have the speed to be able to deploy fast enough to be able to do frequent deployments. So that's one big thing. And then how often do you introduce a change that ends up being so bad that you need to roll it back? So the change fail percentage is the other metric that requires that. And a lot of times leaders will think there's a trade-off so that you have to choose whether you want to be stable or whether you want to have speed. But in actuality, what the report shows us is that these all equal each other. So you have to be fast in order to have stability, in order to have a high performing systems. So why is that, right? One example, or you can look at this like these elite performers, they're doing across the board. So usually you don't have one metric being really good and the other or, usually all 4 of them are at the same time doing a little bit better. So elite performers, it takes less than 1 day to get a change into production. It takes less than an hour to restore service. I mean, think about how important that could be. And you can deploy on demand, or you can do multiple deploys in a day with a 0 to 15% change failure rate. And so if you're able to do one, it leads to the other ones, right? So if you're able to deploy quickly and securely, that means that you have a system in place to ensure that your changes are going to be successful, right? So how we get started on this, first is, creating that culture of psychological safety, but it's both, productivity as well as organizational performance. So there's lots of different activities on both sides that you can use to get started in this. And you have to kind of pick and choose, like, what is the biggest area for you where you want to get started. So what is a mission critical system, right? I think a couple people here work on our government contractors of some kind. So you're aware of like how those systems are dangerous or how important they are to people. I mean, some of our applications are supporting millions of people, like tens of millions of people who are, trying to get refugee status or trying to get asylum in the United States. It could be a weapon system. I think I have a slide in here on the nuclear codes, which just migrated from floppy disk systems, I think maybe a year or 2 ago. So that's not terrifying at all. There's also, your healthcare systems. This is a system that's going to be inside of someone's body. Like that's a really critical system that you want to be careful about how you're changing and making sure that you're putting the right changes in. And also our financial system. So I think that something like 75% of our trades happen electronically. And there was that major outage or incident not that long ago, maybe it was 10 years ago now, where there was a bug introduced and there's all these like strange trading patterns that happened. So that's certainly something that could happen and a scary thing to break or to mess up. So when you combine those, it's kind of like drawing the whole story together. Like, why would you need to change so fast? Part of it is because there are these vulnerabilities out there, which are just kind of lurking behind the system that could blow up at any moment, right? So like the timeline, so there's the severity of that, like how widely distributed it is, how difficult it is to access, what is like the privilege level that's required to access it, whether it's theoretical, if it's a proof of concept, or it's a known exploit. Like one example is for Drupal, there was a critical vulnerability that came out that required to be resolved within 24 hours. And most government websites are in Drupal. So that's, you're talking about every single website across, every single federal agency has to resolve that vulnerability within a day. And some agencies just, if you don't have the speed to resolve those errors, you don't have the stability of the system that you need. So that's why that speed and stability comes together. And then the timeline for these, I mean, these exist, some of them exist in your system and you just don't know about it until somebody puts out a report or says it in there. So it could just be existing in your system at any time, right? It's only when we've identified it and then you have to create that patch and then you have to patch them immediately. And it is like within 24 hours, right? Usually. Let's see. And these are happening all the time. I saw a theoretical that there are these vulnerabilities in Microsoft and Oracle, like in pretty much every major technology system that you can imagine, there are these vulnerabilities. So that's why it's so important for us to be able to have that speed and be able to execute that quickly when we have that desire, right? So it's not just about putting out the newest widget or putting out the newest feature or function. It's being able to implement those changes in a safe and reliable manner so that when there are these vulnerabilities coming up out of everywhere, you have the resources to be able to put that fix in very quickly. Right? So this is all kind of related to a bigger topic, a whole like academic science around resilience engineering. So the system is resilient if it can adjust its functioning prior to, during, or following major events, and then sustain those required operations under both expected and unexpected conditions. So this is not only about the technology that you're using, but also the people that you have in place to be able to resolve these issues. And that's what DevOps is really about. It's not just having OpenShift and all these containers deployed all over the place. It's also about having the people in place who have a healthy enough dynamic and a psychological safety in order to work together and collaborate when these issues do come up and to get that system back online or to implement that fix that you need. So for more about site reliability engineering, I would definitely check out this book from O'Reilly, talking about service level objectives and error budgets as well. Is a really exciting concept. I think a lot of people are trying to implement error budgets, but maybe having a little bit of struggle outside of Google. But definitely check out that, read more about that if this is interesting to you. This is about disaster recovery planning and testing. So this is one way you can think about, how well is our system doing on these different types of things. So, have we done an infrastructure failover? Have we done an application failover? Do we have simulations that actually disrupt production like test systems? And some of that is, I think, called chaos engineering as well, as that exciting term, where you're actually testing these systems that you've built, because you might think that you have a great failover or that it's high availability, but have you really tested to see if that's going to happen? Because you want to be able to test that in a safe place and not when it's actually, you don't want your first test of that to be when it's something really bad is actually currently happening, right? So that's, a funny story I heard from a person at Verica is that they set up a chaos engineering day where they were just doing it in staging and they were just going to test a node failover, and it should not affect production at all. And then as soon as they implemented the error, it did take down production. And they're like, well, why did that happen? And it's because there had been an error introduced earlier on that they had not caught. So everyone has this perfect picture in their mind of how they think their systems work. But if you're not testing it, then you don't really know if it actually works, the thing. So that is, I believe, the end of my talk. So I know I did a little bit of a fast version there for you. If anybody has any questions, you can take those now.
Thank you. I did try to post the links to the books and the report in the chat if anybody's looking for them.
Great. Awesome.
Any questions for Victoria? If you have not read through the report, if you do DevOps, I highly recommend it. I think most of us have had discussions about it at some point.
Exactly. And it's just really useful, if you're like me and you're in these situations where people are kind of skeptical of this new buzzword of DevOps and how it could even really apply to them. I think it's just very practical, real examples you can use to push that conversation further and get people really thinking about how their systems work.
Well, and some of it is counterintuitive to people who are used to, like you said, thinking they're choosing speed versus stability, right? Mm-hmm. And it points out that, it's not a choice. You need the speed to get the stability, and you need the incremental development and all that. And a lot of us spend a lot of time having to evangelize this and explain to people why this is a good idea. So.
Yeah, and actually, I think that the government industry does a better job with planning for outages and planning for failovers than private industry does, and that's a DevOps thing to do. Mm-hmm. You're already doing it. You're already doing DevOps. You're here.
All right. Any other questions? Well, thank you very much, Victoria.
Great. And I have to pop away for the evening, but I am on Slack. I'm on DC Tech Slack. I'm on Twitter. So please reach out and chat. I'm happy to talk anytime.
Thanks for coming by. Nice to see you again.
Thank you.
Have fun at happy hour.
I will.
All right. The next one we have up is Derek.
All right. Let me share. Okay, can everybody see my screen?
Yep.
Okay, let me pull it so I'm looking at the camera. Basically, what I'm talking about is how a lot of large organizations, or at least my customers, which I understand is not an independent sample, seem to insist on making a steel copy of a wooden bridge when it comes to adopting DevOps automation and cloud technologies. So let's get into it. Before we get into the steel copy of a wooden bridge, I'm going to level set. And there is nothing on this slide that should be new to you. You probably already know it, but from a business person's perspective, they move to the cloud for a number of reasons. Usually quickly, get cost benefits, get out of the data center business. They'll get global reach and make their applications more performant to the people around the world who are using them. And they get increased speed to market. In other words, they don't have to wait for data center things to happen when they kick off new initiatives. And when they do choose to adopt DevOps automation, a lot of times it's seen as going hand in hand with cloud adoption. Some of our customers are adept enough to understand points like environment consistency, administrator productivity, and reduced error rates, things along those lines. This is nothing new. My only reason for showing this slide is to park this idea, because I'm going to come back to some of these points later on. And we've all seen it, I'm making an assumption. I'm assuming everybody has seen it. But when large corporations run into new technologies and they decide to adopt them, what's the first thing they do? They create a team to support that new technology, or they create a silo. All right. We've all seen it. My customers are replete with multiple networking teams for different of the divisions within that. You see security teams, you see database admin teams. So when they went to the cloud, 3 of my customers at least created a cloud center of excellence. A team that started, went along for a couple of years and then died a mean death. I've seen cloud infrastructure teams, DevOps teams. And the big point here is that essentially that paradigm doesn't work the way it seemed to work for other technologies they used it on.
Hey, Dirk.
Yes.
We're still seeing your title slide.
You're still seeing the title slide. Let me try this again. My apologies. I tell you what, I'm going to. All right. Can you see my slide or see my screen?
Yep.
Okay. Quick review. You all saw this part, right? What I just covered was the beginning of the story. Reasons why enterprises move to the cloud. They're not technology reasons. They're usually business/competitive reasons. And the same thing for DevOps automation in terms of environment consistency, admin productivity, reduced error rate. And what I was about to cover is when corporations do adopt a new technology, the first thing they do is create a team to support it. And I used the word silo. You probably heard me, but you didn't see the slide. This just reiterates what I talked about a little bit in terms of, we all see networking teams, we all see security teams, we all see database admin teams, and we all have seen probably a number of other teams that deal with cloud expertise. Cloud Center of Excellence seems to be the predominant title that I see, but I've seen other titles too. But soon after they adopt the cloud and they adopt DevOps, then problems come in. The first category of problems I'll call sales pitch violations. In other words, places where cloud technologies and DevOps didn't match what the business expected when they adopted, right? You see things like security breaches due to rookie mistakes, people using technologies that they're not associated or not familiar with as much, availability failures, performance issues, and typically with early cloud adopters get those bills the first year. And beyond that, things seem to take longer, and it's a tight labor market. So it's hard getting people to be able to do this. And they take longer because primarily your staff isn't as experienced with the new technologies, which is to be expected. And then you get something else that they don't expect. And I've seen it happen at 3 or 4 customers now. You get what I'm labeling as turf wars. Essentially what happens is the people who automate cloud infrastructure, they end up doing things that the security silo used to do, or the network infrastructure teams used to do. For example, they create virtual networks, subnets, things like security groups, things like NSGs on the Azure side. They have some input into firewalls to protect the perimeter of the cloud. You get all sorts of hybrid cloud issues, which gets cloud infrastructure teams involved in things like Active Directory forest extensions, DNS extensions, VPN connectivity back to on-premise, or ExpressRoute or Direct Connect, if you're looking for something faster. But the big point of this slide is that the old silo system that they were using before they adopted DevOps in the cloud doesn't seem to work as well anymore with this new technology. In other words, they created a steel copy of a wooden bridge, right? They took a set of old technologies or old paradigms that they have. They tried to apply it to new stuff, and it didn't work well. Basically, segue back to the title. What I've tried to get my customers to do is make the paradigm shift and acknowledge that it is a paradigm shift. Instead of trying to square into the new world, basically take a higher level view and redesign their org structure to fit what the new world looks like. Acknowledge right up front that the speed of change will temporarily slow as your staff gets used to doing things in an automated fashion instead of a manual fashion. You say, do it the old way, just do it manually. I'm impatient, I need this thing done. And the problem with that is that then what you've done manually doesn't really match your automation, and you create problems down the line. I also try to get them to declare war on manual approvals. In the new world, basically everything's software. Everything can be programmed, including your guardrails. So instead of having somebody submit a request to make a change, basically automate the guardrails, automate the constraints that you don't want people to do on the other side. So instead of them having to go through a manual approval, have an automatic guard on the other end. I'll even give you an example. At a client, we were diagnosing a network problem, and we opened up a port to the internet temporarily. And within 60 seconds, it was shut down on us, right? I got a nice little nasty gram that said, okay, you're not allowed to do this. And if you need to do it, you need to justify it with this process and go talk to these people. And that's an example of automating your guardrails. All right. And I don't know, given the technical interruption where I stand on time, but I had hoped to kind of turn the tables as a presenter, canvas the group at some point, and Gene, we can do this later, right?
No, now it's fine.
If we're out of time. But I've outlined some of the things that I've advised my customers to do, but I'm anxious to hear from the crowd if they have seen other tactics that I might not have thought of.
Anyone want to jump in?
This is the audience cue to wake up if you're asleep. And if there's not, that's fine. I didn't mean to put anybody on the spot, but if you want to jump in,
I've seen a lot of stuff that doesn't work.
Okay.
So like,
what have you seen?
A lot of organizations, when they first move to the cloud, they do what's called a data center in the cloud. So they're not actually using cloud technologies, and they're not changing their processes to match. So they are trying to manage the cloud the same way they'd manage their data centers that they owned.
Or sometimes even more strictly because it's new and they don't have the experience with it. So they try to be extra slow and careful.
Yeah. Yeah. Rather than, they'll do things like, not allow the developers to bring up and down instances on demand. They have people continue to have forever machines that have to be maintained.
Cattle, not pets.
Yeah.
Yeah, I've seen that too. And what that does is kill some of the drivers for going to the cloud in the first place.
Well, I think the big one is people want to go to the cloud because they think there's a savings, but there's only a savings if you change the way you actually manage your data center.
Yep, agreed.
On the theme of things that don't work, I'd say the biggest issue, and on multiple contracts that I've seen, has generally been, sometimes it's technology related. Like if you have a very old application that has a lot of time under its belt, people are afraid to change it. They're afraid to try something new. But I'd say even more than that is it's people. So you mentioned like teams and creating silos. Once somebody has a team and once somebody has power over a particular thing, they're not very eager to give it up, all in the name of, trying something new. So, and especially if you've carved out something new, a lot of times people want to go and grab it. So that's been a lot of failures there, trying to negotiate with people that just have the political ability to stop you. Some successes, but few.
Yeah. No, you're absolutely right. I see that too. At some level, people understand that in effect, the reverent power has shifted. And they're not part of it unless they do something about it. So,
and they do.
Yep. Agreed.
All right.
I
Anybody
appreciate
else?
the contributions. Thank you.
Thank you, Derek. All right. David, did you have something you wanted to chime in with in that?
Oh, well, just that second the declaring war on manual approvals. I think we've seen a lot of advance in the organization I support just by saying what does the manual approval actually need, and does that need to be could that be automated? And so it's as simple as if you need a federal person to approve every change, every deployment to production, then and you need this document that has the change request. All right, well, can your pipeline create that document summarizing all the files that have changed and all the stories that it's related to? Can you get the federal official to approve the process? And that would then automatically approve any running of that process. That's helped out quite a bit. We've also found that something that has managed our risk has been decoupling release from deployment. So the idea that you can make the software change, and that's not the same as making the change immediately available to end users to experience. That instead is put in a government official's hands who can actually make that decision. That has allowed for gradual deployments that allows us to do good beta testing before proceeding.
Interesting. I like that segmentation of release to deployment.
Anyone else? Great. Well, thank you guys. And thank you, Derek. All right.
Thank you.
Lisa, you are up.
All right. Cool. 100% mode. All right. So today I wanted to talk a bit about tracing. I think that we've gotten to a point where we now have a variety of tools and implementations for adding tracing to our applications. And they've gotten pretty good enough that we can almost kind of plug and play and abstract away how they actually work. But at a high level, these implementations share the same sort of concepts. And I think knowing these concepts can come in really handy, especially when one day when they inevitably break and you're flailing around, at least we can have some educated flailing around. So to kind of take a step back, when I talk about tracing, I'm talking about being able to link together events that were triggered by a particular action. So for example, like clicking a sign up button on a website. All the actions that happen from clicking that button, such as maybe like looking up a user from like maybe your account service or like running through validation. We can group all those events together and call that a trace. And then in your trace, you can break up the little pieces of work that happened. And those can be like arbitrary, building blocks, and we'll call those spans. So over the past couple of years, we've had the explosion in support for the different types of tools for tracing and applications. We have like open source solutions, you can self-host. We have products that are focused on tracing. And then we have, existing APMs that have added on distributed tracing as a feature. I guess I could have added on today, Grafana announced Tempo, which is, I guess, their version of distributed tracing now. So, a lot of options for you. But given all of these possible solutions, ensuring interoperability in like a heterogeneous system is kind of a nightmare without a unified spec. So I'm going to be talking against the W3C spec, which was made recommended last February. And in this spec, they define how we pass around this trace information via HTTP headers. So there's two headers. We have a trace parent header and a trace state header. Trace parent is kind of our standardized information where we have like a version which goes against which version of the spec we're on. We pass the IDs for our trace information or trace ID, a parent ID, which is like the span IDs, basically span ID for the calling, the caller of the request, and some trace flags for like, options that we can do with the trace, such as like sampling. I think that's all we have right now. And then for custom options, like, vendors might have more information that they want to encode in a trace. We can use the trace state parameter, and it's just a key value store. So to kind of walk through how that request path goes. So if we have a request going through our system, you can see that we might generate, a trace ID and our span ID, and throughout our request, as we go from our galactic service into RGS and Barbie doll, that our trace ID is the same. And if we decide to do our splits for our spans, like per service, to just like keep it simple, in each of our services, we can generate our new span ID. And then when we make a request to another service, we pass in that span ID and it becomes like the parent. So that's like the high level information that's being passed around. So I wanted to talk through a little bit of how we could make a compliant, very simple, compliant application that supports passing this trace information. So if say we have like a web application and we have a request come in, we'd have to first parse our headers and look for this trace information and see if we have it. If we have it, then we can use that trace ID, and that is what we set. If we don't have our headers, we have to like generate one, which is just like 32-digit hex. And then our other information like version we could use to like parse the information correctly. Flags, can use to set the information whether we want to like log out the trace or not. But I won't talk too much about version and trace flags. I'll probably focus on the ID stuff. And then since we decided to, oh, we'll just create a span for whenever we encounter requests into our app, we generate one. So given this information, we now have it. We need to pass it along to our next application. So to propagate this information, it could be as simple as just, okay, well, we generated it, now let's encode it. So whenever you make a request, say like when we did the sign up and you call to say an account service, when you call that account service, you could pass along these headers. So you would just have to remember to like get trace headers and then feed it into your HTTP client. So this is great. We now won't break any tracing interoperability across apps, but we're not really using that data. So we could do something as simple as just including the trace information in our logs, logging out trace ID, and then we could run a search or something, and then that could help us as we like track down information. Like going further, we could include some more information in our like tracing, such as like a span name. So instead of just having like a random hex ID, we could specify like, oh, this part of the span is for like fetching a user. We could include stuff like timings, error, context, and so on. We would just have to make sure that we ship this information off somewhere, whether we're handling it or there's a third party to like process and store the data. So with all that, we now have like a basic system and we can use the information. Something that a lot of tracing clients will do will also add in something like auto injection, and this will help add some magic, because it can kind of be a pain, to instrument every single entry and exit point to your application. Like every time you get a request, you have to say like, oh, start trace or something like that. So these clients can take advantage of existing frameworks. For example, if we have like our system has like some middleware that you can hook into that will give it access to a request. So we could take advantage of that, so that way the user doesn't have to care. It'll just happen automatically. So you'll see in a lot of like libraries, they'll specify like, oh, well, you'll have auto instrumentation if you use X, Y, and Z frameworks. And so there's like a lot more you could go into to see how tracing actually works. Some stuff is like language specific, like handling asynchronous requests, or say you wanted to do like back propagation because you have like server side rendered front end application. But I think that's probably more in depth than I wanted to get into right now. But if you wanted more information, you could look up the trace context spec on W3C. If you wanted more information on like standardized information in spans and like more details like that, there's open telemetry, which is I think still in beta, but a lot of products are like already up to spec with that. And yeah, so I'm hoping the TLDR tracing can be just as simple as passing around IDs, and we want to store some information with them, and that's all you really need. So, any questions?
Yeah, actually, I have a bunch.
Oh boy, okay.
How do you normally, so this is a great way to get, to gather, like you said, distributed transactions and kind of gather them all together and be able to read through what a user did and all that. How do you usually integrate this with logging and stuff? Do you, is this something easy to do with Splunk to follow this? Does it make it easier to parse that type of stuff? How does it play with kind of those types of tools and maybe the application performance monitoring tools that do this type of thing as well?
So it will depend on your application. For some things, it could be like, oh, you just have to like log out the trace ID or something. But for some of the tools, you could say like just enable distributed tracing mode, and they will start including that information, and they will handle parsing in the HTTP headers, and sometimes even injecting it outside into other requests. If they follow like W3 spec, it's kind of nice because you could have multiple like tools in your system, but since they all read from the same headers, then they can all use that information. Did that help?
Yes. And are these like the header, the trace IDs and span IDs, are these, I guess, close to at least global GUIDs or something, so that, you know, if I wanted to try to push this out to an entire enterprise and say, hey, from here on out, start including these in your apps, like all new apps should adopt this, because it makes our, you know, auditing, it makes our tracing so much easier down the road. Is that something we have to do a lot of coordination, or is it just if everyone just starts doing some, are we in pretty good shape?
So if some people start doing some, you're gonna get some, I think, valuable information, even just having it in like 2 applications. If it's, you know, where a lot of debugging happens, it's very useful, at least in my experience. And it depends a little bit on whether like you are already using APMs and they already support distributed tracing, because then it could just be like turning a flag on, like literally. If you don't have that set up, then it would be the usual process of like, oh, like adding that kind of tool to your application.
Cool. Thank you. Anyone else? I don't want to monopolize all the questions here. Nope. All right. Well, thank you very much. This is actually really good. I already have a note to myself to hand this one over to my, once I get it up onto YouTube, to hand this over to my team, because we're trying to make recommendations to a group, you know, best practice type thing. And it seems like if we could inflict this on them early and get them to buy into it, then, you know, it'll save us problems later when we decide, hey, we really needed something like this.
Sweet. Oh, and the cool thing with open telemetry is if you use that, then you can ship it off to like multiple backends. So if you use New Relic and you use Honeycomb, if for some reason you want to send it to both, should be fine.
Cool. Thank you. Thank you very much. All right. David, I think you are up. We're not hearing you, David. There we go.
Try that again. Excellent. I'm David Bujard. I'm an Agile coach at ECS Technology, and I work as part of Team Sabre, which is Sabre is short for Sabermetrics. Sabermetrics is the analysis of in-game data to drive improvements in baseball, and we help our organization, our wider organization in the government, improve their DevOps practices. Let me tell you a bit about some of the business challenges that we have. So these are not just technical challenges. These are problems that we have when bringing data to groups, to different development teams and Agile programs and DevOps programs in our federal organization. Our team's mission is to turn the track record of Agile programs into an audit-ready story that's visual, fact-based, and compelling. And part of that is to give our programs audit defense, but the primary reason is to help drive improvements in our organization. So we generate a lot of charts. We bring a lot of data. We'll look at our systems, find some actionable insights, bring those to the programs that are doing the work that generates that data, and have conversations. And naturally, we are welcomed with opened arms, and people are delighted to have the data that we have. that we share with them? No, not at all. In fact, there's this swirl of emotion that accompanies those conversations. And we've learned over time how to handle those conversations in a way that avoids this particular storm. Because generally, data really can be encountered as a form of grief if it's something that you're not used to looking at. In particular, instead of Kubler-Ross says the cycle starts with denial, we find it starts with anger. And in particular, it's all about role within the organization. So if you're crossing organizational lines or simply bringing unwelcome news, you will get a lot of pushback, which is emotional. We say to ourselves, yeah, we just had a conversation which was all about emotional reactions to color choices, right? You throw red on a chart and people take it personally. And the intellectual point you were trying to share gets a little bit lost. Even when we are delivering data, unwelcome data to clients who have commissioned us to do this, right? We're taking it directly to the people who gave us the assignment. You will see them kind of flush through this stage of anger. Sometimes we'll get into the stage of denial, right? So we've delivered unwelcome news, and there is a lot of talk about, oh, is this really right? Or let's double check this data. I remember one architect who every time we brought him something would always say, oh, but this data that says that we have, 900 help desk tickets that were filed in the past 2 weeks, that's wrong. We had 902. Well, nitpicking the data is an emotional response, right? It's just a phase in the stages of data grief, and you have to kind of work through it. There is an alternative to working through this kind of resistance that gets in the way of having real improvement conversations. And the solution really is to don't cause the grief to begin with, right? If you just know you're going to run into denial and anger, then let's just sidestep it entirely. So our main go-to position has been, if we're bringing data to a new group and having a conversation and we're trying to build up a data-driven culture, let's start with the good, right? Let's start with the good. And when they say, who are you and what are you doing here? Our answer is, we are here to share success stories across this organization. And we've found something that your organization is doing well. Let's have a conversation about it to make sure that our data is correct. And you may have something else going on here that you need us to help clarify or tell the story more accurately. In doing this, we're building up data allies, people who have sidestepped the anger and denial. And now, interestingly enough, nobody ever nitpicks our data when we're telling a positive story, right? So we've shifted the conversation into not whether data is acceptable at all, but, oh, how can we use this data, right? And we're building up an investment in the relationship that can pay off when we're ready to share some data that is not, in fact, good news, right? So some of our key takeaways here as we do that. We lead with our success stories. It is striking how using a story and making it positive helps information cross organizational lines. That's the envelope, the package that you need to deliver actionable info. As we do that, the purpose is to build up the practice of using data. So the important part is that the data is correct. We do not need to draw conclusions, or if we draw conclusions, we need to be very conservative about our analysis of what is happening, right? Our purpose is to build up the practice of using data for performance. It does not mean that our purpose is to tell people how to do their business. No. So frequently that means we're going to dial back. We're pretty sure that what's going on here is the security folks are not talking to the developers, right? But we don't say that. We just simply bring them data that says the average wait time between a story being marked complete by the development team and marked ready for deployment by the security team is 30 days, right? And if we tell that story, then the improvement conversation can flow from there. However, if we do have that kind of information that's a little edgy, right? It's prompting an improvement conversation, but it's not necessarily an unmitigated success story. We're going to make sure that we go to that team and get review, right? We're going to do it early on. Hey, here is some data. Are we looking in the right place? Right, real basic questions. And then as we're getting closer to sharing the data, often in the form of the success story, we're going to double check and make sure that our presentation of that story really works for this particular group, because it's worth the pain of provoking all that anger and denial is not worth the cost that we'd have to pay that moves us away from using data for improvement. It leads people to say, no, this data is not important. Better to review it privately, right? And so in particular, if it's bad news, there are times, so every 6 months, there are programs that come before a review board, and they're basically deciding, do we want to continue funding this program? And we are asked to present a roundup of data about what has happened with that program. We will have a strong bias towards presenting what is happening well within that program. And if there's a problem that we see, we're going to make sure we've previewed it with that group first, right? Because we never want to surprise people with bad news in public. That causes less reliance on data for improvement. And finally, don't underestimate the power of when you tell a success story, you're establishing the ground rules of what good looks like. So simply saying, we particularly recognize these programs as delivering more often than they used to deliver, right? You're establishing that frequent delivery is the metric that matters. Frequent delivery is something that everyone should begin tuning towards, because our leaders in the organization care about that. And that's the metric that's used to tell the success stories across our organization. So choosing what to highlight becomes powerful. With that kind of information, we build data-driven cultures, right? We build a data-driven culture. We connect with across different parts of the organization. Ideally, we're building it. We find what measures are moving people, and then we make that self-service, right? We're going to build some automations to collect and visualize that. And then we find that the charts we produce are in fact being kind of copied and pasted and inserted into PowerPoint presentations that are being sent around the organization, right? Because we've taken the time to make it sound self-service. I think I'm largely running out of time, so I'll be very brief. Earlier, Victoria did a good example of the kinds of things to measure, and I'll refer you to that conversation heavily based on Accelerate and the State of DevOps reports. I will say the king of our measures has tended to be frequency of delivery, so just counting the number of deployments to production. And if our organizations get that metric moving up, then that solves so many other issues. It also solves cycle time and predictability questions. It makes the requirements much more relevant, right? It begins to solve the problem of stale requirements or unsatisfied users. All of which you can begin to count, round up in a balanced measure, presented regularly, and emphasize and dial up the good. So that's how we navigate the different stages of data grief. Any questions from the group?
How successful have the simple dashboards like this with just the red, yellow, green been for conveying?
I will tell you that that's not the red, yellow, and green is somewhat the bane of our existence. It compresses the conversation about what good looks like. Fairly often, if we can get, let's take some measures like this. This in particular, this chart is showing the amount of is one of the quadrants in the chart below, which just says the number of tests, the amount of test coverage, code coverage within an application, and how does that compare across different applications. having a series of visual charts sounds like a good idea, but we keep finding that our customers need very simple measures, simple messages, right? We need to keep it simple. And consistently, our federal counterparts will come back and say, I need a red, yellow, green, right? I can't really judge this myself. I need you to summarize it. The downside is then if you ever show a red, you're going to have a lot of conversation, right? Even a yellow is something that we work with carefully. So we've tried to build some automated ways of differentiating when people are beginning to diverge or move in a negative direction. So yeah, we just kind of have to meet our customers where they are.
Yeah, I think, my reaction is always those. It seems like a great way to summarize the data and give everyone a good point to look at, but it immediately starts following Goodhart's law, which is, as soon as you set a target, a measure, it becomes a target, and
right.
Everyone starts using that as the goal, and you get heavily into your bargaining stage of why things shouldn't be. Why there shouldn't be a yellow and it's really a green, and don't worry, it'll be completely green next week and you don't have to worry about it now. So
we do find we go out of our way to make sure that we're presenting a measure that, if gamed, will be gamed in a healthy direction. So number of deployments, right? You want to game that? Okay. It'll still be better than 4 times a year, right? And 40 times will be better, and 400 times will be better than that. So that works well. We simply counting we steer clear of story points. We count the number of individual stories delivered, and that, again, when gamed, you game it by having very small stories, and frankly, that means higher quality and lower risk. So thank you for your questions and your time. Oh, go ahead.
Feel you've been successful with steering the gaming that way?
Yes. If you make it easy to get the data, and you've established that this is the way we count things in an organization, then it is striking that is indeed the way that the organization continues to expect. You've kind of trained them to expect certain kinds of numbers. Now, this takes a while. We've been doing this for at least 4 years, and it was really only around year 2 that we're building a strong alignment around, look, if we just count the number of frequent deployments. And we had some strong leadership, executive buy-in as we were doing that. We're still fighting the battle with cycle time, for example. So people will have different ideas about what good looks like, and sometimes people will still say, well, is it a bad thing if it takes us 4 weeks to deliver a story? That doesn't mean it's a bad story, does it? Right? So we have to orient, and if we keep presenting that cycle time, that small batch metric over time, we think that bargaining will fade.
So do you think this has helped them progress through their data grief, their visualization grief?
In particular, the making sure that we're not going to use data as a club. So the dialing up the positive, focusing on the success story makes a world of difference. And it's a fairly quick difference, right? It's the difference between spending 2 weeks trying to build relationships with an organization, and it's going to get nowhere if I come in and say, hi, we're here to assess you. But it proceeds very quickly if we say, hi, we're here to share success stories across the organization, and we see some signs of something that's going on well within your group. Can you help us verify to make sure that we've got our data lined up, right? We've already led with, we're not going to make you look bad. We're going to work collaboratively with you, and we acknowledge that you may know more, you do know more about this than we do, right? All of which are signals that help people work with you to get the data right. And they get then bought in. They can't argue that this is not a metric that you should measure if they've been using it to brag to their colleagues.
Nice.
How do you end up dealing with that one group that's not doing well, that's all reds? And They're
Um,
the holdouts.
Generally speaking, we try to, when possible, we try to avoid side-by-side comparisons. And instead, we establish this is what we're measuring. So for example, there's one program that we worked with, 20 different development teams, all within the same program. Lots of requests to say, show us the good teams compared to the bad teams. We want to find the bad teams. And our approach was, let's build alignment that we're going to use data to improve, and let's make the data visible. And so we'll provide this information for the whole program. Across those 20 different teams, all supporting one system, this is the number of deployments that that system has, or the amount of code coverage that that system has, with contributions from all those different teams. And then we build alignment that we care about high code coverage, which was something that people push back on early, right? And we care about frequent delivery, which is something that sometimes people said, well, it's okay if we can go, a day or half a week without a deployment, right? And as we avoid using data as a club, we get alignment about what good looks like. Then we also got the people who are not looking good by those measures seeking us out, saying, yeah, what can we do to get our numbers up, right? And then we have conversations about improvement. Other questions?
Cool.
Thank you all.
Thank you very much, David. All right, I think I am the last one to go. So let me switch over my screen here. A second. All right. Okay, so I want to talk about trust and specifically the ongoing cost of not trusting your teams or your organization. And while I think most people will generally agree that trust is a good thing, I think the value of trust is often underestimated, or more to the point, the cost of not trusting, or the tax you pay by trying to impose control is far more expensive than most organizations will realize. And it's a cost that you keep paying on everything you do, and so it is a tax, right? It's a constant additional burden that you incur and that these other leaner, faster teams somehow manage to do without. Organizations often really like the idea of controls and processes and approvals, and guardrails, I think was the term that Derek used, that to keep the teams from doing the wrong thing, from causing problems, from making mistakes. They don't just do it because they're mean or vindictive, hopefully at least, but generally because they've been burned or they've been hurt before, right? They've seen something go wrong in the past, and they don't want them. They just don't want that to happen again, right? They're trying to learn from their mistakes. But there's a fine line between guiding the team with lessons learned and immobilizing the team with oversight and controls. So comedian Will Rogers once said that good judgment comes from experience, and a lot of that comes from bad judgment. And it seems to support the idea of putting processes in place to prevent the team from failing, right? Sort of a slow and steady wins the race attitude. Stick with what you know works. We'll get there eventually. But most of us today's world can't afford to move at the tortoise's pace, right? So in today's agile environments, we tend to look at the risks differently. We accept that mistakes are going to happen despite the best plans and the strictest controls. Best we can hope for is to constrain the blast radius. I think, I kind of like the automated guardrails that Derek brought up, right? And declaring the war on manual approvals is another one that I like. What we're trying to do is constrain the blast radius. Most of the time, things are going to work out okay-ish, at least, maybe not perfect, but few large explosions. And if we're practicing continuous improvement, we are going to approach everything as a small experiment, right? And sometimes they work, sometimes they don't, but we're going to keep getting better. right? Amazon founder Jeff Bezos said, if you're good at course correcting, being wrong may be less costly than you think, whereas going slow is going to be expensive for sure. And this is something that I tend to see a lot in our projects. If we treat everything as a chance to learn, to build that good judgment that Will Rogers was talking about, then failures aren't a bad thing. And if we're keeping the blast radius small, then it's not really costing us much. So Thomas Edison said about the light bulb, I've not failed 10,000 times. I've not failed once. I've succeeded in proving that these 10,000 ways will not work. I think most of us already agree with this, right? But what's the cost of not letting teams fail? Like, what if we could just keep them from making those, 99 failed attempts first, right? How does it relate to trust? Well, in the way it normally materializes in the projects I work on, certainly in federal government consulting a lot of times, can you imagine if Thomas Edison had to fill out a stack of paperwork to be approved for every one of his 10,000 attempts? He knew that he was moving forward with an experiment. Try to see if this works, right? He trusted he would fail, learn, and try again. None of his failures were likely to be fatal or catastrophic, so he accepted a small amount of risk as a trade-off for progress and learning. So how many of you work in an environment that takes a week or more to approve the use of an open source tool, even when that tool is something popular, well-known like Docker or Chef or Jenkins? How about a month, right? How about 3 months or longer? And what's the cost to your team, right? How much does it slow you down? One of my personal successes on a recent project was getting Chef stood up and configured in development only. It wasn't even in production. The project manager was so excited when I presented it, and he mentioned it represented, quote, a year worth of work. I pointed out that they gave me the go-ahead to do the installation once I got back from lunch, and it was now 1:30. So it represented less than half an hour of work, but it was a year of twiddling my thumbs, waiting for approval to work through the approvals to work through the process. On the other hand, what they could have done was trusted that Chef was legitimate software and wouldn't have exposed the organization to huge risks. And like Derek said, we could automate the guardrails and have pieces in place that would make sure I wasn't going to do anything that was going to incur a large blast radius, and we could have moved forward quickly. Another one was, I guess, getting to his declare war and manual approvals. How many of you have been in an onboarding process that means a new employee takes more than a day to get access to your work systems, or more than a week or a month, right? And you start calculating in a year how much labor cost is wasted just waiting for your own organization to allow employees to contribute value, right? And that doesn't include the lost opportunity costs or employee attrition due to boredom. I worked on one project with someone that gave their 2 weeks notice just after 6 months. They'd been on the project for 6 months, and they got their system access to the project a week later. They were never given the opportunity to contribute meaningfully to the team, but they cost the project 40 hours a week for 6 months. The project could have given him access that he needed on day one, and trusted that the process of hiring someone conveyed trust that they were allowed to have system access to contribute, but instead they had all the approvals, all the manual approvals, all the hoops that had to be jumped through, and the ending result was, they spent half a year of time and lost the person because he was just too bored. This type of thing is one of the reasons that unicorns of the industry, the startups, they could be so much more productive, because they just haven't put all these processes in place to slow themselves down, so they don't even think of it. It may not even have been an explicit thought of let's not have these problems. They just haven't gotten around to putting the problems into place, putting the processes that are causing problems into place. Woody Zuhl of Mob Programming Frame has a great quote, but you're trying to give employees and the organization enough of a safety net to reduce the blast radius, limit the cost of failure, maximize the opportunity for learning and improving. And it really leads us to another type of trust that your teams can adjust to do the best they can, and that they will adjust. They're the ones that see the hurdles they need to go over or around. They're the ones that can adjust quicker. They're the ones that can do the right course correcting. Woody says, if you can't trust the people you hire to get the work done, you have to get better at hiring or at trusting, right? And it kind of goes along with Steve Jobs. who said, it doesn't make sense to hire someone smart and tell them what to do. We hire smart people to tell us what to do. Right? Backseat driving isn't effective. The driver in the front seat's in the best spot to see what's coming, to make the adjustments to the course, to the speed, to slow down when needed, right? And all of that it also goes into trust and to the tax you're paying by trying to slow somebody down. So if you want to be effective, you're going to have to reduce the ongoing tax you pay, and you're going to have to trust your teams, right? Trust that they'll see the right ways forward, that they'll build a safety net so that you can be confident that they won't fail too badly along the way, the reduced blast radius, right? If we're trying to prevent failures, however in vain it's going to be, we're still slowing down the learning. We're inhibiting progress. That's part of the tax we pay, the reason we're not moving faster. We're constantly betting against the team, assuming that serious failure is the most likely outcome, and taxing them by making them move slowly and jump through hoops to prove that they're on the one single known path to success, which ensures they're never going to find a better path or a shortcut. This is the, Victoria mentioned the change fail percentage is one of the key metrics in the Accelerate State of DevOps report. The change fail percentage tends to be lower if you move quicker, and even on medium performing teams is less than 15%. So if you're making the bet against the team succeeding, you're wrong 7 times more often than you're right. So why would you make that bet, right? You bet that they're going to succeed, because even without putting too many restrictions in place, they're going to succeed more often than fail, right? And like I said, all of that adds up, as far as I'm concerned, to a tax that you pay, that people incur. And I just don't think teams understand how often or how expensive that tax is and what it costs them. All right, that's what I had. Thank you. Any questions for me? I know we're getting kind of late here.
Somewhat off topic, was that last picture from your desk at FFM?
No, it was from Matt Reeves's desk, who's my current team lead or branch lead, at his desk at TSA.
Okay. I seem to recall you having something snarky at FFM.
Yes, but I love that one. We do it to ourselves, because that was his argument at a lot of times, that most of these problems that we're running into, what I call the tax, is self-inflicted, right? If we just got out of our own way, we'd be better off. But in the name of safety or protecting the teams, we end up spending more time. And in fact, more to Victoria's stuff, if you go in and look at some of the stuff they write in the Accelerate State of DevOps reports, if the mean time to recover is low enough, then the blast radius is always small, right? That is what you're doing. You're making small problems, not big problems when they happen. The lead time is a perfect example of a tax, of the tax. It's a great way to measure it, right? And cycle time or some of the other stuff that David was mentioning, that those are all little pieces that all go and show you that this tax is real. And I know I did a talk one time on some of the problems we ran into at a DoD project, and half the people in the room were kind of nodding their heads saying, we get it. And half the people in the room were like, why is this so tough? This is all easy. We work at startups. We do this all the time. Why is adopting DevOps not automatic? This was a number of years ago when it was still a case you had to make. But the big thing was, they just didn't have that tax, and people in the DoD space and the government space are used to having that tax, and they don't think anything of it. They think the safety matters more in their mind, what they're considering safety.
Any idea why some people are or organizations are so risk adverse to the point of, basically getting in their own way?
I think it's a learned response. They get smacked down when they do it, and they say, okay, well, I'm not going to do that again. Right? There's a lot of times, I think Tom has talked about this a number of times, that a lot of times the incentive system is such that you are penalized for doing wrong, but you're not rewarded for doing right. So there's no real benefit to you other than the general good to do the right thing. And, people tend not to be
Yeah, the
altruistic
incentive
enough.
system is around not failing.
Yes.
It's not around succeeding.
Yeah.
And
Yeah.
you want your incentive system to be around succeeding.
Well, that does also speak to what David was just saying, right? If you set up the metrics to say, hey, it's just to show that we're getting better. It's just to show that that teams are doing well. We're going to make you look good, rather than, hey, this is the club we're going to come in for, right? That's the same type of idea.
Yeah, the hard part is making it not be a club,
Mhm.
right? Because as soon as you make something a metric, someone's going to think that's a good club for me to use.
Yes. Yeah, and Tom, and you and I have been in places where they said, give us this number. Don't worry, we're only going to use it for good. And then as soon as you show it for the whole organization, they say, okay, now give us that same thing and break it down by individual developers so we know who to fire in our next layoffs. So.
Yeah, definitely, it happens. Or you need to increase this number to get your bonus this year, without context as to what that number even means.
Right.
And that's an interesting thing in building up trust, is when the conversation is more about system effects, then the point about, we can't afford not to trust each other, where it becomes higher. So just quantifying it, you give the example of how long does it take to get for a newly hired developer to get their first line of code into production, or simply get set up and able to build complete a build. Those kind of weighting metrics are powerful, because nobody can take the time it takes for a developer to be up and running and say, okay, we're going to fire somebody because of that, right? It becomes obvious that it's a system problem, and you can take that and say, hey, a leader who's really interested in solving problems, here's a problem for you to solve. How long it takes for that request. Request should not take 1.5 years to complete, right? And they can realize, oh, well, maybe that is something that I can deal with. And it becomes a more positive, constructive environment, even if their default is to use that data as a club. We're still giving them a problem to solve, but it's the right problem.
Yeah, I think kind of along those lines, one of the things we've tried to do on my current project and on a couple of the previous projects as well is, we're standing up a system, stand it up in a commercial cloud environment on the side. And usually we can manage that just while we're trying to figure out the applications or the installation instructions. There's nothing proprietary or anything about that with the agency we're working with or with the organization we're working with. And then we turn around and show it to them and then do it again on their network and jump through all their hoops and try to show them, hey, what we're seeing, this difference in speed, right? We spent a week and we learned it all and we did it over there. And now we're spending 3 weeks to do it here and we already know what we're doing. That's the tax you're paying, right? It's even worse than that 2 weeks, because that week we learned, this week we already know what we're doing. And it's still more expensive here, and start understanding that you're incurring a really, really heavy tax here. And this is why you hear things like, these, the FANGs, the Facebook, Apple, Amazon, Netflix, Google, that they can turn things out multiple times a day and continuous deployments, continuous delivery and all that. And you're not seeing it because you have all these processes in place and this tax is so huge. And now you're getting into the point where you can't get cycle time up, and meantime to recovery is really slow because of all the paperwork that has to be done, and nobody has the authority or incentive to move quickly. And it all starts to break down.
Yeah, you would think that would work.
Yeah, you would think. It seems to work locally. The individuals we show seem to get it. It does not seem to translate to organizational wins of, hey, maybe we'll step out and try to change the process so that everyone can experience this win.
Yeah, I'd like to say that was true too.
So
I have certainly seen it work, not even on the individuals.
Someone has to have some skin in the game, otherwise, it's not hurting their job.
Yep. And again, the incentive system is, hey, I didn't fail, right? As long as I'm not
Or-
worse.
If there was a failure, I have someone to blame it on.
Yes. Yeah. Step one: find a scapegoat in case things go south.
Yeah.
All right, Michael, you still there?
Yes. Thank
Has
you
this-
all.
Has this been helpful?
Oh, yeah.
Not too cynical? All right. Well, thank you all for coming. Like I mentioned earlier, the next month is going to be an open discussion. So if you're around, please join us. It is, let me get back to the date again. It's, come on up. It's not showing up. Oh, there it is. November 18th. So favorite DevSecOps tools. And we're just going to have an open discussion around it. So please join us if you can. I will post in the meetup group with the link tomorrow of the YouTube video if anybody wants to see it. And yeah, thank you all.
Thanks, Gene.
Thank you.
Thank you.
Thank you.
Bye.
Bye.